Okay. Well, hopefully you guys enjoyed a few moments of a break, and I know some of you guys are still running back to your rooms and conference rooms, getting back into the session. So I'll just speak for a little bit longer, and maybe if you hear my voice, you realize the good stuff is about to come online right now. So we have Paul about to kick it off here. There were several questions related to clustering, load balancing, recommended load balancers, things of that nature. So we're going to let Paul make sure that he covers that. So Paul, you can go ahead. Let's hear your voice real quick. Can you hear me?
Yes, I can. Can you hear me?
Fantastic. You're coming through strong. Go ahead and do your desktop share. As I said earlier, Paul is our application server clustering lead. So he is the guy who can talk to you all about App Server 7 specific configuration and capability as it relates to setting up a cluster, getting the load balancing working, high availability. So we look forward to having Paul for the next several minutes, next 45, 50 minutes of a presentation and a set of demonstrations, and then he'll be able to also answer your questions towards the end of his session. Well, take it away, Paul.
Okay, great. Bela should be joining us soon. He's just having some connectivity issues. So my name is Paul Ferraro, just really quickly. I'm the lead for JBoss Application Server Clustering. So I'm responsible for all the clustering subsystems in JBoss AS. Bela, who should be joining us shortly, is the overall lead for JBoss clustering, including all the clustering projects that we have going on. Moving on to the agenda. First, I'm just going to talk basics. How to enable clustering, how to indicate that you want your deployment to be clusterable. Then I'm going to dig into the different clustering subsystems, including JGroups, Infinispan, and Mod Cluster. Then after that, we're going to talk about some of the details about what's new in the new versions of Infinispan and JGroups that AS7 is releasing with. And then afterwards, Bela's going to talk about scaling in general and AS7 and cloud readiness. So let's start with the really basic stuff. So Brian talked about starting AS7, but how do you start AS7 with the clustering subsystems enabled? Well, as Brian mentioned, there are two ways that you could start JBoss AS. If you want to start a managed domain, the default profile that domain XML comes with doesn't have any clustering subsystems. It does contain a separate profile called HA, which does have the clustering subsystems in it. So what you do to enable clustering in the domain case is you just indicate that the profile that you're using to start your given server group should be the HA one. And you also need to make sure that the socket bindings that you're starting that server group with does include the HA sockets. And then you can just start the server using domain.sh as Brian showed you. And as he also mentioned, the difference between domain mode and standalone mode actually has nothing to do with clustering. Clustering is available in both modes. In the standalone case, there are actually different configuration files which contain different sets of subsystems. And the configuration file that contains the clustering subsystems is called standalone-ha.xml. So you can start the standalone process using that specific server config. So without further ado, I'll actually show you that. So I've got my terminal, two windows. First I'm going to start one JBoss AS server, which contains the clustering subsystems. So one of the things that you may actually notice, the server starts crazy fast, but second, you don't see any channel start, even though I've started a server instance with clustering enabled. And I'll talk about that on the next slide. I want to go ahead and start another standalone process. Before I do, one of the common questions when dealing with clustering is that 500 two server instances on the same machine, how do I do that without port conflicts? One of the simplest ways is to just have each server instance bind on a separate interface, which is what I've done here. So I've taken the standalone DAS HA XML and I've cloned it, called it HA2, and given it a separate bind address. So the first bind address is my loopback, and the second is my actual public interface. Alternatively, I could set up the socket binding group for my second server instance with a port offset, which will actually go ahead and increment all of my binding ports accordingly. So if I go back here and just start my second instance, I also want to specify that I want to put any let's see. So the server it creates a data directory which contains some of the files that it needs during runtime. So if I want to start a second instance, I actually want to have it use a separate data directory. So I'll start a second instance. As you can see, also no clustering, sign of any clustering going on. So why is that? Let's move on to the next slide. So where are my clusters? So one of the differences with AS7 as compared to its predecessors is that all the clustering services start on demand. And when I say on demand, I don't just mean that a channel is created but not started until an application needs it, but I actually mean that the services themselves aren't actually started unless there's a clustering deployment out there that demands it to start. So this is probably, when I was trying to decide on a demo to show, I thought this was going to be the most interesting thing to show. So I just wanted to show a quick life cycle example of what I mean by starting channels on demand. So I'm just going to hop back to my file system and show you the old school way of deploying an application. So if I just drop my simple war into the directory, you'll see this file shows up that indicates that it's deployed. If back here, you can see that here's the all too familiar indication that a JGroups channel has started. You'll see that appears on both servers. It's got one distributed web application deployed on both of my servers. So I can go ahead and deploy a second distributed web application. And as you can see, that doesn't start an additional channel. It doesn't start an additional cache either. So I've got two distributed web applications deployed on both servers. Now, the starting of the channel isn't actually associated with any specific web application. It's actually been demanded to start and will only stop when it's no longer needed. So if I actually undeploy these out of sequence, if I undeploy the first one first, and I can do that by deleting this deployed file, this will actually undeploy them up on both servers. So you can see that that's happened on both servers. And finally, when I undeploy this second web application, you'll actually see that not only has it been undeployed, but the clustering resources itself, the channel and its cache, have all stopped. So I've now sort of returned to a pristine state where I have two servers running, no clustered deployments, and therefore require no clustering services. So that, I think, is probably the most interesting change in AS7 as compared to AS6 and earlier. So moving on. So I just want to talk about what makes a cluster deployment. Basically, nothing's really changed since AS6. If I have a web application that I want to make distributable, I just add the distributable element to my web XML. Simple as that. When a distributed web application is deployed, those sessions will be stored in an Infinispan cache container. So I'm sorry. Cache containers, and I'll get into this in another couple slides. Every Infinispan cache container is named, so the different so web sessions, as opposed to stateful session beans or as opposed to entity beans, are cached in different cache containers. So web stuff goes in a web cache container. Clustered stateful session beans, you indicate that you want it to be clustered the same way you did before, using the clustered annotation. One thing to mention is this hasn't actually been implemented yet. It will probably land early on in the 7.1 cycle, but stateful session beans use the SFSB cache container by default. The other aspect of that you might want clustered is your JPA second level cache. Well, by default, the second level cache isn't actually enabled. You have to enable it manually. You do that through your persistence XML. You say use second level cache equals true. But one thing that has changed in AS7 as opposed to earlier is Infinispan is now the default provider, regardless of whether you're clustered or not. The advantage of which is in AS6 and earlier, if you were using a second level cache but not clustered, you would get a hash map implementation, which unfortunately is prone to out-of-memory errors. It had no mechanism for eviction or expiration. So in AS7 we're now using Infinispan as a default provider, which also means that you don't need to actually specify a region factory class in your persistence XML, which is something you needed to do before. Now you get that for free, so you'll get eviction and expiration support even in local mode. And whether or not you're clusterable depends on the actual configuration of the Hibernate cache container. So if you have a clustered application but you just want basic second level caching without clustering support, all you need to do is make sure that those are local caches as opposed to the default, which is an invalidation cache, which will actually broadcast invalidation messages to the remaining cluster members. All right. So now I want to talk about the individual clustering subsystems and what's different in AS as opposed to its predecessors. So in AS5 and AS6, if you wanted to customize the JGroups configuration, you had to look inside the all profile and inside this specific JGroups configuration file. That configuration file held the protocol stack configuration for your server. In AS7, as Brian mentioned, all configuration is stored in one place, and that includes JGroups itself. It's stored in the JGroups subsystem, and I'll show you the guts of that in just a bit. Okay, I'll show you it now. So this is what the JGroups subsystem looks like. You'll notice it's not exactly the same as the JGroups config that you're probably used to. The scheme is very generic, whereas native JGroups, the elements and attributes are specific to a given protocol. In AS7, things are much more generic. So if Bela wants to add a new protocol in the next version of JGroups and you want to utilize it, there aren't actually any schema conflicts. So this, the JGroups subsystem schema can actually handle new, both new protocols and new properties as they appear. So the other thing you'll notice about the JGroups Subsystem schema is there aren't any ports or addresses. All of those are externalized. So they're externalized by socket binding definitions. So, if you look here, so my UDP transport is referencing a specific socket binding. Diagnostics is also referencing a socket binding as well as FDSoc. And also, if you looked at AS6, there were a lot of custom property settings. Those custom property settings are sort of hidden behind the scenes. You can change any JGroups protocol property, but you don't need to be concerned with the default settings. They don't need to be sort of reiterated. So the general improvements to this mechanism for defining your JGroup stacks. The default stack that all clustering subsystems use is defined in one place. Now in AS6 we sort of did that, but we leveraged system properties so that every clustering subsystem would define the stack that it was using a system property, which could be used to toggle the default protocol stack for all the subsystems on a given server. In AS7, there's a default stack attribute which says, okay, all of my clustering subsystems are going to, by default, use the UDP stack. If you want to switch to TCP, you change it in one place. I mentioned already the generic schema and the advantages to that. We externalize socket bindings, so all the socket bindings are stored in one place. If you're starting multiple servers on a machine, you can utilize the port offset and get all of that logic for free. We also externalize thread pools, which I'll talk about a little later. So the thread pools that JGroups uses can be specified, shared across stacks if you wanted, and port registration is another thing. So all of the ports that JGroups uses behind the scenes all get registered with the AS's socket binding manager. So if you want to see in the admin console all the sockets that your application is using, you also see which JGroups sockets are in use. So a little more about socket bindings. So here I've defined I'm showing you all the socket bindings that JGroups uses by default. The interface that they reference is also externalized. So if you want to change the binding interface for all of your JGroups sockets, that's in one place. You can see these are the socket bindings for the UDP stack. These are socket bindings for the TCP stack by default. So if you want to change any of these, this is where you go. So if you want to customize the protocol stack, as I mentioned earlier, the default properties are stored they're actually stored in a file which you can reference if you wanted. Basically, all of the protocol properties that we defined in AS6 are the defaults, so they don't show up in the default AS7 config. But if you wanted to see what those defaults are, you can look at this file here. If you wanted to override any property, they're override using a sort of generic schema notation as well. So for example, if I wanted to amend my UDP stack and enable bundling, which will take if I'm sending lots of broadcasts, I can bundle them into groups and send them out as a bundle as opposed to firing them off one at a time. So you could turn that on quite simply just by enabling bundling. This another example of how you would change the TTL. So moving on. So managing JGroups threads. If you by default, JGroups manages its own threads. If you wanted stricter control over that, you can externalize all of JGroups' thread pools and utilize the thread service. So this shows you an example of how I would actually do that. So there's a separate thread pool for out-of-bound messages as opposed to the regular inbound messages. JGroups timer service. All of those can be externalized. And this is an example of how you would do that. Moving on to the Infinispan subsystem. So in AS6, the Infinispan, all your Infinispan configuration was stored in one file, which was here. In AS7, it's now stored with everything else, as was mentioned before. So the Infinispan subsystem looks somewhat similar to Infinispan's native configuration file format with some sort of key differences. One difference is it actually stores multiple cache containers. So in native Infinispan, you need a separate configuration file for every cache container. This subsystem lists them all. Cache containers are named, so they each have a unique name. So, for instance, web sessions all get stored in caches within the web cache container. Some other differences, if you look at any of these cache container configurations, there is no global element, which is something that shows up in the native Infinispan config file. Global usually defines things like your transport, executors, whether you're using your JMX settings, etc. All of that is done under the covers, and you get all of the wiring for free. Some of the other differences are the way you specify your cache mode. So these are basically just schema differences, even though there's a resemblance between the two, but there are some differences. So the other main difference to point out is the way a default cache is specified. In native Infinispan, there's a separate section which identifies a default cache, and then you can have separate named caches which inherit from the default cache, which one of the lessons learned from AS6 was if a user wanted to change the default cache, say for their web session replication, actually changing it was a little bit awkward. So you either had to change it specifically for each deployment, or you had to actually kind of reorganize your XML. So what I've done in AS7 is made it a bit simpler to do that. So if I wanted to change my web session replication to use distribution mode instead of replication mode, I just change it in one place, which makes things a lot easier. So talking about general improvements to the subsystem, specifically to how it's configured, toggling the default cache, as I just talked about. So the schema also only exposes the configuration that's relevant for a cache mode, which is a difference between this subsystem schema and the native Infinispan schema, which AS6 used. So no longer will I be presented to be able to configure an L1 cache for replication mode, because that doesn't exist. So just general schema improvements. Cache containers are also all bound to JNDI by default. So that's all done under the covers when the subsystem is first loaded. Now, just because a cache container is bound to JNDI doesn't mean that the cache container itself is actually created or even started. This is one of the other big improvements in AS7. Is the binding is actually what's actually being bound is a reference to a factory which knows how to actually create and start the service. So I can actually create the JNDI bindings ahead of time, but the services that they represent don't actually get started until they're first looked up. And I'm going to show you in a couple slides how we actually leverage that to do some interesting things. So other improvements, we can also externalize thread pools the same way we did in JGroups. So customizing Infinispan caches, there are 4 cache modes that you can use: a local cache, replicated cache, which can be sync or async. Distribution mode, for those that aren't familiar, distribution mode is differs from replication mode in that cache entries are only replicated to a specific number of servers. This has some similarities to buddy replication, which you may be familiar with from AS5 and earlier, but has some advantages. And invalidation cache, which is largely used mostly by the Hibernate second level cache. So the other thing I might want to customize is, say I want my cache container to use a different protocol stack than everybody else. There's a separate transport element where you can specify that stack name and make it different than the others. Another way you might want to customize an Infinispan cache is to have it start up eagerly as opposed to lazily. Like I demonstrated in the beginning, caches are started lazily, so they're only started when there's a service that demands it to start. For instance, deploying a distributed web application will force the cache that it relies on to start. If I actually wanted a cache, say, if I had a cache that I wanted available immediately, then you can specify it to start eagerly. Let's see, Jindy binding. If I wanted to override the Jindy name that a given cache container is bound to, I can specify it using the Jindy name attribute. The Jindy name can be a relative name, and if it's relative, we'll assume that you mean the global namespace. By default, things get bound to the JBoss namespace. So here's an example of how I might want to externalize my Infinispan thread pools. You can externalize the thread pool used by the replication queue if you're using asynchronous replication. The eviction thread pool, which is a timer-based thread pool, as well as if you have any asynchronous cache listeners or cache manager listeners. Those can be externalized, as well as the thread pool used by the transport itself. All right. So how would I change which cache I wanted a specific cluster deployment to use? In the web session case, you can deploy your web application with a JBoss-web XML file, which inside contains the cache name that you want to use. By default, we use the default cache for the web cache container. You can override that using the cache name element. Same goes for stateful session beans. And how is that cache name actually interpreted? Every cache defined in the Infinispan subsystem is associated with a service name, as well as the cache containers themselves. So if, in this previous example, I had defined my cache name as web.dist, that actually refers to the web container, and within the container, the dist cache. So if there's no prefix to that cache name, we assume that you mean jboss.infinispan as the base. So if I specify web.dist, I can then interpret that as a full service name of an Infinispan cache. I can also leave off the cache name to refer to the default cache. So you can think of the default cache name for a distributed web application to just be web, in which case it uses the default cache for that container. For the second level cache use case, if I wanted to customize the cache used, that needs to be specified per region. And if you see at the bottom here, this is how. I mean, this is no different than AS6. How do I specify which cache I'm using within a specific cache manager? Now, the integration for second level cache uses Jindy, which is also the same as AS6. But one of the big differences is in AS7, this Jindy lookup doesn't actually require that cache container to actually have been deployed and started beforehand. The fact that you have a JPA application that uses second level cache that's using this Jindy lookup, that itself will force the caches that it relies on to start when that application is deployed, and then will force that cache to be stopped, or that cache manager itself to be stopped when that application is undeployed. In the same way that I demonstrated earlier when I talked about services starting on demand and stopping when they're no longer demanded. And this is sort of an extreme example of that. If I wanted to actually reference, if I wanted to use Infinispan directly in my application, say, here's an example of a managed bean using the various CDI annotations to actually inject a cache container into my application so that I could use it. So if you see here, I've got the resource annotation, and I'm looking up a cache container. So this cache container isn't necessarily started until the application which contains this managed bean is actually deployed. And as you can see here in my post construct, I actually get the cache, which will start the cache if it's not started already. So when this application is undeployed, this cache manager or cache container, I use the two synonymously, gets undeployed along with any of the caches that it started. So this, I think, is kind of one of the more interesting things that's going on in AS7 in terms of how clustering services are started and stopped. So moving on to Mod Cluster. Now, Mod Cluster was one of those services where its configuration was entirely contained in a microcontainer configuration. So if you wanted to configure Mod Cluster, you had to weed through all of our dependency injection logic and weed through various beans in order to get what you wanted done. In AS7, Mod Cluster has its own subsystem. Its configuration is quite simple. As you can see here, it really is quite simple. There are intelligent defaults, and by default, the only thing I need to actually configure, if I wanted to, is the advertised socket binding that Mod Cluster advertise will use. I'm going to assume everyone's familiar with Mod Cluster. If there are any questions about it, you can ask later. But this is sort of a huge change, and I think is quite wonderful. So the general improvements configuration is much more concise. You don't have to weed through class names, component wiring, or any of that. If you wanted to customize the load metrics that Mod Cluster uses to determine the load that it's going to broadcast to the load balancer, that's also quite simple as well. And as I showed you, socket bindings are also externalized. So how would I configure Mod Cluster? Let's say I'm running in an environment where I don't want to use multicast, and I want to specify the address of my load balancer explicitly. What I do is I get rid of the advertised socket binding, and in its place I enumerate the proxy. I enumerate the address and port of the proxy, or of the load balancer itself that I want to communicate with. If by default, Mod Cluster is going to make available to the load balancer any web applications that are running on your server If I want to exclude any of them, you can enumerate those using the excluded contexts attribute. This is an example of how I would exclude the root context and my foo context. So how do I customize the load metrics that ModCluster uses? If you remember in AS6, the load metrics, you had to specify class names and had to know various properties that they defined. It's a whole lot simpler to do that in AS7. The load metrics, the different types that are supported are enumerated. So you just refer to the specific enumeration that you want to use. So in this example here, I've got ModCluster configured to calculate its load using what's the CPU load of the machine that it's running on, and how many sessions does the server have relative to its capacity, so how many sessions can it actually handle. Load metrics can be weighted as well, and if you look here, the history, this indicates how many load values am I storing, and the decay is what indicates how significant previous loads are in terms of the final load that I'm calculating. So think of it as a time decay factor. Okay, so we're now going to talk about some of the sort of new features that are introduced in Infinispan 5, which is what AS7 is shipping with. AS6 shipped with Infinispan 4.2, so the fact that we're shipping with Infinispan 5 means there are a few more features that you can leverage. And a lot of these we're actually using under the covers. So in Infinispan 5, there's some new transactional behavior. Infinispan is a transactional cache, which in 4.2 meant that it registered its own XA resource with the transaction manager, which meant that if you had an Infinispan cache involved in a transaction that, say, also included a database, that you were forced to then use a two-phase commit, and Infinispan would then participate. In Infinispan 5, they've added the ability to register with the transaction manager using a synchronization, which really helps out in terms of performance if the only other resource involved in that transaction is, say, the database, which means that the transaction manager will be able to optimize and use a one-phase commit as opposed to two, because a given transaction only has one resource that's involved in it. So that's something that we enable by default in the Infinispan subsystem. They've also implemented recovery, which means you can use your XA. The XA resource can be configured to use recovery or without. Using recovery obviously carries with it some more overhead, but adds the ability to be durable. Okay, other new features. In Infinispan 4.2, the AS required anything that you stored in the cache, everything would get serialized eagerly and then deserialized lazily. The reason why you need to do that is so that let's take the example of web sessions. If I'm putting a user object into my cache, well, only my application's class loader is actually going to be able to deserialize it. So that needs to be done lazily, so that the class loader needed to deserialize is actually available to Infinispan. One of the things that was added in 5.0 is the ability to control that separately for keys or values or both. So we actually set that behind the scenes. If you have a local cache, we don't actually need to do that eager serialization and lazy deserialization. So store as binary, which is how it's been renamed, is disabled entirely. For distribution, distribution mode and replication mode, we enable that. So this is sort of the default behavior in AS6. And so what's interesting is in validation mode, the only thing that ever gets sent over the wire are cache keys. We never actually, in validation mode, you're not actually replicating your cache values. So entities that you stick in your cache don't get replicated. Only invalidation messages for a given cache entry get replicated. So we don't actually need to serialize cache values for an invalidation cache, which is a big win in performance over what we had in AS6. Also worth noting that's new with Infinispan 5 is the MapReduce API, which extends the distributed execution framework that was available in 4.2. That includes this really cool API, which allows you to basically take a computation and parallelize it across the cluster and be able to come up with, to be able to take a task and distribute its execution and come back with a meaningful value. Manic did a great presentation at JedCon that shows an example of this, where he takes, I believe he takes the text from War and Peace and analyzes it and counts what's the most popular word found in War and Peace. So it's kind of a cool example of how you would use the MapReduce API in a real-world example. And there's a link to that at the end. So at this point, I want to hand over to Bela to talk about what's new in JGroups. Is he available?
Yep. Can you hear me?
Excellent.
All right. Thanks, Paul. So I've got a couple of slides on new features in both JGroups and clustering, and I'll talk about a little bit about JBoss in the cloud. All right, so the first feature is something I talked about at JBoss World, which is the ability to connect separate clusters into one large virtual cluster. So if you look at the slide, we have a cluster. On the left side, we have a cluster in New York City, a local cluster consisting of A, B, C, and D. And we do have another cluster in Zurich consisting of W, X, Y, and Z. And these local clusters, they basically, they could be using IP multicasting, or they could be using TCP. Let's assume they're using IP multicasting. What now happens is that this new feature in JGroups connects the two local clusters, or local sites, into one large virtual cluster. So applications that are running on top of JGroups, such as Infinispan or AS clustering, basically think that the cluster consists of A, B, C, D, W, X, Y, and Z. So they think it's a large virtual cluster, but the most important thing here is that New York City and Zurich are completely autonomous. So Zurich doesn't depend upon New York City. New York City doesn't depend on Zurich. What can you do with this? One of the things you can do is place backup copies into Infinispan. Infinispan being used as a store, a data store, distributed data store, and we could tell Infinispan to store 2 copies of every key in New York City and 1 copy in Zurich. That would be the backup copy. Or we could do it the other way around, 2 copies in Zurich and 1 copy in New York City. When the entire cluster in New York City fails, we would then, or the clients would then transparently fail over to Zurich, and the data would still be available. So this can be used for geographic failover. That's one of the use cases. Another use case is that Zurich, as acting as the backup cluster, could be used for data mining purposes, because the data is basically copied from New York City to Zurich, and it's available in Zurich, so we could use it for data mining. This is a feature of JGroups 2.12, which is currently in AS7. We intend to actually use JGroups 3 in the final version of AS7, or basically AS7 1. And this feature will be part of JGroups. We have to discuss internally whether this will be productized. I certainly hope so. Okay, next slide, Paul. Thank you. So one feature that's new to JGroups, and that's an ongoing feature, is Ergonomics. We try to minimize the configuration of JGroups. In the best case, and that's the goal actually, you will only have to specify what transport you want to use, TCP or UDP. TCP using multiple connections to all the nodes in the cluster, and UDP using IP multicasting and basically sending one message to all the nodes in the cluster. And potentially we would ask questions such as, would you like state transfer, do you use distribution or replication, and do you need fragmentation, and so on and so forth. But the goal would be that the user only needs to specify a list of protocols and does not necessarily need to specify the options inside of the protocols. And that's a big issue for us because a lot of people misconfigure a stock configuration of JGroups and then run into problems. So what we're trying to do with Ergonomics, and that word is, by the way, borrowed from the JVM, is to sense the best values for a given protocol and adjust the properties of a given protocol dynamically. So that in the best case, again, that's the goal, people would only have to list the protocols they want to use and not define any of the properties inside the protocols. So why do we want to do that? One size fits all isn't good because sometimes you have small clusters. The properties of small clusters are different from the properties of large clusters. Sometimes you have clusters in the cloud, which, for example, don't allow for IP multicasting. And whereas private clusters benefit from IP multicasting, so the goal here would be to switch automatically to basically sense in what environment a JBoss cluster is running and adjust the properties of JGroups dynamically. So this is, as I said, this is ongoing work, and some of this will already be in AS7 and 7.1. Okay, next slide, please. A new feature in 2.12, which is also part of AS7, is daisy chaining. So this is mainly, or can be mainly used for a cloud, where IP multicasting is usually not available. I don't know, actually, currently, I don't know any cloud provider who provides IP multicasting. So when you run JBoss in the cloud, you need to use TCP. The problem with TCP, though, is that when you want to send a message to 10 nodes, you have to send the message to the first node, to the second node, to the third node, so you have to send it 9 times. Whereas with IP multicasting, you just send it once. So that's not very scalable. It basically stresses certain lines to, or certain links to and from the switch, whereas IP multicasting is much more, easy on the switch. So daisy chain is basically a model where, I don't want to go into details, but where you pass a message on to the neighbor, to your neighbor, then your neighbor passes the message on to the next neighbor, and so on and so forth. So basically the sender doesn't need to contact 9 peers or 9 cluster nodes, but just 1. And the benefit of this is a decentralized model where the load is not, just on one link to and from the switch, but it basically distributes the load across all of the links to and from the switch. There's higher throughput. However, this also yields slightly higher latency. So if you have a latency-sensitive application that needs to run in the cloud, then this would have to be turned off. Again, this is good for some applications, bad for others, and that's where Ergonomics comes into play again, because we want to dynamically basically turn on or turn off daisy chaining based on the environment in which you're running. For example, are you running in the cloud or are you running in a local cluster? By the way, there's a presentation I gave at JBoss World on the first one on geographic failover, And there's also one on running JBoss clusters in the cloud. There, I'm talking about this in a little bit more detail. Okay, next slide, please. Large clusters. So that's one of the goals that we have, support for large JBoss clusters. And when I say large, I mean clusters between 100 and 1,000 nodes. There are certain use cases for such large clusters. However, I have another presentation 2 years ago at JBoss World where we can use mod cluster domains to actually partition a large cluster into smaller subclusters. So instead of having 1,000 node cluster, you might as well have 10 100 node clusters. And how this is done, you have to Google for my presentation, JBoss World 2 years ago, 2009, I believe. Okay, however, the largest known cluster, JGroups cluster, that I've personally seen is 536 nodes. So I think we're on a good path to actually reaching 1,000 nodes. This is very important for the enterprise data grid. This is the Infinispan product, which is basically a distributed grid, a data grid. And it runs on JGroups. And of course, you want to have a grid that's sufficiently large. So right now, we can support up to 500 nodes. I believe we just haven't been able to test on a larger cluster, but I believe we should easily scale to 1,000 nodes. But this is ongoing work. Right now, the next target or medium-term target would be 2,000 nodes. This requires configuration changes, again, for optimal performance. Some of the properties of the protocols have to be changed. But again, the goal here is to reduce the number of changes through ergonomics. We want to, for example, we know how many nodes there are in the cluster, and based on the number of nodes, we can change certain parameters. So the number of nodes would be a function that basically generates an optimal value for certain properties, so that people do not have to set any of the properties in any protocol in JGroups. Okay, the last two slides is about AS7 in the cloud. So we announced OpenShift, which is an environment to run JEE applications, and obviously you also want to deploy clustered applications. And so one of the work items that actually that work is completed is better integration with OpenShift. OpenShift uses a special software or library to actually cluster or basically to discover their nodes, and we actually hook into that cluster and get that information from the OpenShift subsystem, and therefore a JBoss cluster will actually support OpenShift optimally through this special integration. So the goal here is to start cluster nodes via OpenShift. You just tell OpenShift how many nodes you want to run through currently Express or Flex, and then OpenShift can dynamically start or stop cluster nodes to basically maintain a certain cluster size. So if your load, for example, if your load increases, you can dynamically or automatically start additional nodes. If the load goes down over time, you can kill some of the additional nodes. So there are policies that can be defined in OpenShift to do this automatically. Deploy apps to the entire cluster. This is actually a feature of AS7 or AS in general, where you can deploy, using the domain service. Brian talked about this, where you can deploy applications to an entire cluster. Okay, next slide, please. Cluster management is certainly something that we're going to be doing as part of the AS7 domain management model. And the last bullet item here, support for more clouds. Currently, JBoss runs, or a JBoss cluster runs in all of the clouds that we know of, as long as they support TCP. But of course, there could be better support for specific clusters. For example, we have specific support for AWS, the EC2 cluster by Amazon, and there we also hook into S3 for discovery, but we can do the same thing for other clusters such as Rackspace Cloud Store. So for example, we could be using something like Rackspace Cloud Store for discovery. Of course, we could also use the existing JBoss discovery mechanisms, but then Rackspace Cloud Store might be more efficient if it's used directly. Okay, so these are some of the things that we are going to be doing in AS7 in the clustering subsystem. I think that was my last slide. Can you flip to the next slide, Paul? Yes, there's some links. The JBoss World presentations I mentioned, running a JBoss cluster in the cloud, is one of them. This basically shows how to run a JBoss cluster on EC2. And then Geographic failover for JBoss clusters is a presentation that talks about the Geographic failover. That's going to be part of AS7. Then there's Enterprise Data Grid, which is the Infinispan product, the Infinispan Data Grid. OpenShift, there's information on openshift.org. And Manic's JutCon presentation can be, I think that was from last year. Actually, from this year. It's called MapReduce on the cloud. If you search for JutCon 2011, you'll find it. Okay, I think that's it from my side. Bert, you want to take over again?
Yeah, we need to take some questions. We've kind of gotten to the top of the hour, so realistically we're out of time. But I do want to get a few questions answered if we could. Brian has done a great job answering questions that he's been able to address in the Q&A panel. But for you and Paul specifically, there are some specific questions you might want to look at here. So I'll just read them out to you. Okay, specifically, can you change JGroups configurations, update them, change them on the fly for all nodes from the domain controller without starting and stopping the cluster nodes?
Okay, I'll take this one, and Brian can actually pitch in as well. I don't think this is possible because, well, it depends on the change. If you use a completely different configuration, then the nodes that are restarted would basically not understand. They wouldn't be able to talk to the existing nodes, so therefore they would actually form their own cluster. So I don't think this is possible. However, having said that, there is a possibility using Probe, which is a JGroups internal tool, to tweak properties into certain in certain protocols. For example, you could increment, just as an example, increment the fragmentation size dynamically in an entire cluster. This is somehow a covert channel, though. This is kind of going into a cluster through the back door. And I think, and Brian would probably agree, that this is something that needs to be done through the domain management.
Yes, I would agree with that. I think, in general, we want things to be done through the domain management. Any property in the configuration, it basically depends on how the subsystem was integrated, what effect trying to change some attribute on some configuration will have. There's alternatives where the attribute could essentially, the description of the attribute could say that changing it requires a reload or a restart of the server. If so, it's possible that it would depend on the attribute in the JGroups configuration whether that would be required or not. In general, though, I would think changing the configuration of a running JGroups channel would most likely, in most cases, would end up requiring a reload of that service at least.
Let me add something to this. 2 years ago, JBoss World, I gave a presentation on Mod Cluster. I think it's also available as a webinar. And there, if you, I briefly mentioned this, if you have 10 clusters of 100 nodes each, then you could actually change the entire configuration of one cluster by taking the cluster down, deploying the new configuration, and then starting that cluster again. And that cluster in mod cluster terms is called a domain. So unfortunately, the same term as the AS domain. But basically, because we're separating domains from each other and they only talk to the clients through mod cluster, it would be possible to actually take an entire domain, and again, that's a mod cluster domain, down, change the configuration, and bring it back up. But that requires that you actually run Apache HTTPD with mod cluster.
And that domain has actually been renamed to load balancing group, specifically because of this conflict. So if you're looking for that configuration option in the mod cluster subsystem, it's called load balancing group.
You know, another question that came in over the wire, and I thought was interesting, is do we still have support for HA Singleton? Where'd that guy go?
We will. It's not implemented yet. I have some ideas for how to improve it. In AS6, an HA Singleton was essentially a server-level object, and in AS7, I'd like to make it more of a deployment-level object and to be as easy to use as clustering a stateful session bean. So my idea is to be able to kind of piggyback onto the concept of an EJB singleton and to be able to just add a clustering annotation onto an EJB singleton to achieve the same behavior.
Now, here's one I've not heard of before personally, but do you have a configurable policy to alter the behavior when a split brain phenomenon occurs? Who can address that one?
Let me try to answer this. The problem that happens when a split brain occurs is, can you access the different halves of the brain by clients? So for example, if some clients can access the left half and some clients can access the right half and they change state, what happens when the partition goes away and you basically have to merge the application state back together? From the JGroups point of view, I can't do much here. All I can do is detect that the partition has disappeared and basically try to bring the two halves back into one. So in terms of cluster, you have a full cluster again. But because I don't know anything about application state, I have to defer this decision to the application. The application does get a callback, but as you can imagine, if you change the same state on the left and the right side, how are you going to merge it? So one of the things we can do here is we can basically say we can actually implement a policy that says if you have 3 nodes or less out of a 5-node cluster, if you have 3 nodes or less, then basically become read-only. If you have 2 nodes, become read-only. As soon as you have 3 nodes, become read-write. That means clients would be able to access the cluster, but they would only be able to read stuff, but not write stuff. We're saying that you have to have a majority of nodes being up, 3 nodes, and then you become, writable. So that would be just a policy to prevent, the 2 sides of the brain being updated by different clients. But that's basically something that the application has to do.
Okay. Well, let's try to get one more in. I know we're way over our time limit, and there's actually 2 more right at this moment. We'll take those because I think they're both particularly interesting. And so this one from Vishy, he basically is asking, or she's asking, is there any heap size calculator specifically based on how many nodes are in the cluster and what the overall estimate is for the distributed cache model? I could definitely see how that would be of interest to some people. How much heap do I need based on the number of nodes in the cluster and the amount of data I'm trying to put up there?
There isn't any calculator per se, just in terms of it's pretty easy to calculate yourself. based on the number of backups that you're specifying when you're using distribution mode and how many nodes you have and how much heap you have available at runtime is something that's somewhat easy to calculate.
Do we have a wiki or anything that do you have a wiki or anything that helps provide someone with some instructions on what that simple algorithm should be?
Well, if you look at the Infinispan documentation on distribution mode, you can get some idea of how you might do that calculation yourself.
Okay. And I think that's perfectly fair. But I do see that as a common question. I've seen that one before. And the other is I'm currently using cache as a JPA2 level 2 cache. Do you think that should change with what we see now with AS7?
No, because when you're setting up your persistence XML, you have to define your region factory, which you've explicitly set to be cache. So in AS7, that value will be respected.
Okay. Well, at this point, we're 10 minutes over, so thank you guys very much for your presentations today. Bela, great job. I know you had some technical difficulties getting on the line. Paul, absolutely fantastic content from you. Brian, great demonstrations, great energy, so thank you guys all very much for your presentations today. And for all of you guys who stayed with us for the full 2 hours, thank you guys very much for holding on the line with us. We look forward to your questions and comments. Always hit us on Twitter if you want to. You can put the hashtag in, JBoss AS7. And there will be plenty of people monitoring for that hashtag, looking for your tweets. If you have any positive comments, we'd love to hear them. If you have negative comments, keep those to yourself. How about that? I'm kidding, of course. Feel free to email me. All of you guys have my email address in most cases, based on the fact that I was the email address that invited you to the session. You can always email me, and I'll try to get your questions answered as fast as I possibly can. And look for our recordings at jboss.org/webinars. So we'll get those links posted as soon as we possibly can, get these recordings pushed out there. Okay? Well, thank you guys very much.